Hey guys, let's solve a very common interview question, LeetCode 242, that is valid anagram. We are given two strings S and T, and we have to check if both strings are an anagram of each other. Two strings are anagrams if they contain the exact same characters, possibly in a different order. For example, anagram and nagaram, they are both anagrams, so we will return true. But rat and car are not anagrams of each other because rat has T and car has C in it. So the goal is simple. Do both strings have the same characters with the same frequency? The approach to solve this is by using the frequency array, which is the fastest method with constant space too. So here's the idea. If the lengths of both strings differ, we would instantly say not an anagram and return false. Then we can just create a list of size of length, and in this case, I would make it length 3 for visualization. Then I would loop through both strings, and in S we have R. So for R, I would increment it as 1, and in T we have C. So for that, I would just add C as 1. In the next iteration, there is an A and an A. So I would add A and increment it for S, that is first string. And in the next string, I would just decrement it and this would become 0. In the next iteration, we have T in S. So I would just add T over here and mark its value as 1. Here in the T string, I have R, but we already have R in our list. So we would just decrease the count and it will become 0. Now that we have traversed to both of the strings, if our list contains all of the values as 0, it is an anagram. If it has non-zero values, it's not an anagram. In our case, rat and car are not anagrams because C and T are still 1. I would also dry run it later in the video with a longer example that is an anagram, so please watch till the end. This approach is super efficient and avoids sorting. In other case, you could have sorted both strings and then compare them. If they're equal, then they're an anagram. But that would take it to n log n time complexity, but with frequency array, we can decrease it to big of n. Now let's quickly go through the code and then we'll try run it. First, we'll check if the lengths of both of the strings are equal. If not, then we'll return false. Next, we'll create a frequency array of length 26 for characters A to Z and initialize them with zeros. This will track how many times each character appears. Now, I loop through both strings at the same time. When I see a character in S, I increment its count, and when I see a character in T, I decrement its count. Why increment one and decrement another? Because if strings are perfect anagrams, every +1 from S will cancel out -1 from T, and at the end, all frequencies should be exactly 0. An ORD character converts the character into its ASCII number. For example, ORD A is 97, and ORD S of I minus ORD A gives us values between 0 to 25, which matches our frequency array indices. Finally, I check the frequency array for count in frequency array. I would check if count is not equal to 0, then return false, because that means some character didn't cancel out, so it's not an anagram. If all of the counts are 0 and it has successfully come out of this loop, we would return true that this is an anagram. Now let's quickly dry run it with this example. Here I have created this frequency array of length 5 only for visualization, but in reality we would be creating it of length 26. So starting from here, we would check if length of both strings are not equal, but in our case both strings are of length 7. So we would proceed next and create a frequency array of length 26, which we have already created of length 5 for visualization. Next, there is a for loop of length of S, which is 7. So here we would find the ASCII number of S to find its indices and increment its value with 1. So on S, we have A, so we would increment A as 1. In the next statement, we would do the same for T and decrement its value. So on T, we have N, so we would decrement its value as -1. Now, in the next iteration, we would do the same for S, that is N. So increment N and it would become 0. On T, we have A, so we would decrement it and it would become 0. In S, we have A, so increment A and it will become 1. T has G and it would become -1 after decrement. S has G and it would become 0. T has A and it would become 0. S has R and it would become 1. T has R and it would become 0 again. S has A and it would become 1. T has A and it would become 0 again. S has M and it would become 1. T has M and it would become 0 again. Next, in this loop, we would check if the counts in the whole frequency array are 0. If they're not 0, we would return false. But in our case, all of the counts are 0, so it will come out of this loop and return true. That means that both of these strings are valid anagrams. Now let's submit this and compute its complexity. So the time complexity for this code is big of n because we scan through each array only once, and the space complexity is big of 1 because the array size is always 26, and this is the most preferred solution in interviews. And that's it. This is the most optimal and interview-friendly solution to the valid anagram problem. If you found this helpful, don't forget to like and subscribe for more LeetCode tutorials. Thank you and have a great day.